So today will be our first class. In this part, we are going to talk about introduction to telecommunication systems and services. And basically, we start with the simplest model of any communication system. As you can see here, there is a simple model which comprises of sender, receiver, signal, and transmission medium. So in this simple model, we just represent a communications system. And when we say communications, it should not be necessarily the electrical type of system, the sophisticated systems that we know of. But from the earliest periods of mankind, there was also communication. There were signals of flags or something else in order to show what is happening, like fire on the mountain or something like that. So in that case as well, you have the sender, the receiver, and also transmission medium. And also there is feedback. That's encoding, decoding, these are new terms. But during earlier periods as well, things or signs did have meaning. When some sign was shown, it has got meaning. And that was, what we call communication system model. So in communication system model, basically you have all the necessary elements that are essential, which can be also taken seriously when we talk about telecommunications, which is also considered as some subset of communications model. In telecommunications, we take the previous model as it is, but we introduce additional terms like communication of information by electronic means and also over some distance. These are essential additions. So therefore, when you say telecommunications, it is communication of information by electronic means and over some distance. And we need to understand the capabilities, costs, benefits, because in telecommunications you have different systems. Basically, most of them have the same service to pass information from one point to the other, from one end user to the other. But the mechanisms and also the approach, the protocols are different. Therefore, in this course, we are going to learn about those trends in telecommunications. We will assess the systems as well as the services, and we will discuss many technologies. As such, this course will basically touch every aspect of the communication system or telecommunication system, the past and the present and also the future. So we are going to discuss different issues regarding telecommunications. So you should note that telecommunications is some subset of communications. Communications is in the wider sense, and telecommunications when you have all the technologies, electronic technologies, and also when you consider distance. When you have that, you have what we call telecommunications. The meaning should be clear. We have different types of telecommunications networks. You can take, for instance, PSTN, the public switched telephone network, which is used for voice services. There are so many local networks, local exchanges exist, and these local networks or local exchanges will get connected to higher exchanges, and all the networks of those higher exchanges creates what we call the long distance network. So it consists of local networks interconnected by a long distance network. By the way, this applies to any other technology as well. If you have cellular mobile network, it is part of the PLMN. You can have a local base station. That base station is controlled by some DSC. and also that base station controller also is connected to a certain system. So if you take, for example, in this, you have about, let's say, 4 or 5 MSCs, which are systems by themselves. And therefore, you have this same type of scenario in any technology. Because as telecommunication system, the concept of distance is applied, whether it is a wired or wireless type of system. So there is a regulation, like this regulated by government, although there is private trends. This is also different issues. I mean, the policy and also the type of service provision, whether it is the regulation is in place, whether it is privatized or not. All these issues will be parts of the discussions that we are going to have in this part of the course. So to make things clear, there are end users. When we say end users, we are talking about customers and also which are trying to get service and getting service. They are known as end users. And also subscribers, and the subscribers, when they are engaged in a certain system, you can call them end users. So provide input to network and recipients of network outputs, basically like that. So the wider domain is the subscriber, and then from the subscribers, there are users at a time, at any time t. Therefore, we call them end users. They can be part of a system or parts of different systems. Like in this, for instance, in this case, it can be considered as a system. And also, in some other instances, one end user can be in one system and another end user can be at long distance, for instance, abroad in another system. But anyway, end users are categorized, in the subscribers. The subscription might not be to a certain type of or one type of system. You can have mobile to fixed to mobile calls, something like that. In both cases, you have end users. So employs an input-output device. For example, you can use computer, telephone instrument, cellular, PCS telephone, or combined device, facilities or conference TV equipment, even some machines. They can be used. When we say end user, we don't refer to only a certain type of device, like the one that is used for voice or the one that is used by data, but all sorts of services provided by a certain system are under consideration. And in all those services, the subscribers, so the customers at that instant, are known as end users. The other is discussion of the nodes. When you have a point or junction in a transmission system where lines and trunks meet. This is important. We have a node, and then after that, you can have, for instance, some sort of trunk formation is there whenever you have multiplexing. So you can have different nodes within a network. Accordingly, you can have multiple nodes, and in this instance, for example, this is the end user, this is the trunk part, and this is also another node and another end user as well. So in this part, you have multiplexing or other types of tasks being done. So it also performs switching functions, and plus sometimes we call them local exchanges, and also we can call them in the wireless sense base stations. So this is referring to that. In a LAN, for example, a network interface through which one or more end users may be connected is what we call the node. So we are clarifying some of the terms that are going to be used in the discussion, in the upcoming discussion that we have in these trends in telecommunications services and systems. The connectivity issue connects an end user to a node and possibly through other nodes to some final end user or destination. So in IEEE, this is the definition of connection. Connection is an association of channels, switching systems, and other functional units set up to provide means for a transfer of information between two or more points in a telecommunications network. So the idea is to create that type of scenario. Telecommunication creates connectivity, and in this process, there are 3 sequential stages to be followed. For instance, in a telephone call, you have call setup, and the other is information exchange, which we call session, and the other one is call takedown. So setup time is there, and also after that, there is a certain session in which the exchange of information takes place, and then in the end, there will be call takedown or just closure of the session that is underway. So this is what we call connectivity. When you talk about connectivity, we have to also see another point known as the subscriber loop. Subscriber loop is very important concept. In wired system, you have wired local loop, or in wireless system, you have wireless local loop. So these are essential. This subscriber loop is the initiator of the traffic flow to a certain system. The whole randomness and also the carried traffic is determined by the subscriber loop's capability. There can be offered traffic, and from the offered traffic, according to the grade of service, only a certain amount, some certain percentage will be taken by the system. Like if you have grade of service 2%, therefore 98 out of 100 calls will be entertained. The other 2% will not be entertained. This type of scenario exists. So therefore, this subscriber loop is essential. The provision of channel element to the system, to the user, is based on the availability of the subscriber loop. So in a call setup, a circuit is established and activated. User the action of taking the telephone instrument out of its cradle, and then telephone set passes current. The current source is a battery, resides as local, serving switch. It is connected by subscriber loop. So this is just to give you some example. This is the switch, as you can see, the battery feed, bridge, and then subscriber subset is here. The line between this local exchange and the subscriber or the customer is known as subscriber loop. The provision of this loop can be wired, as is shown in this diagram, or it can be also wireless. In both cases, this is essential step. If this part is efficient, then a lot of traffic can come to the system, and if this is bad, with respect to the signaling or other physical sources, then the network performs to generate the traffic in the first place. In other words, this means connectivity is initiated or connectivity is done by using this subscriber loop. So this is very important part. You should understand this subscriber loop. Subscriber loop is part of the access of the system, of core. So the subscriber loop is basically the one that constitutes the access part. So you have to make sure that you understand the terms that are being, told right now. The other is the subscriber loop and the trunks. As I told you earlier, the subscriber loop connects the end user to the local exchange or local serving switch. As you can see, there are so many subscriber loops in here. And the task of the local exchange is to multiplex the information coming from each source and then create some sort of hierarchy, or according to a certain protocol, this multiplexed data will move from one local exchange to the other. The process of making sure that happens, the process of availing the necessary paths for the multiplexed data is known as trunking. And And this trunking process creates what we call trunks. Therefore, this is part of also traffic engineering course, which means you should have a certain type of protocol in order to move large volume of data from one exchange to the other. And while you do so, you need to have trunks which are different from the subscriber loops in capacity and also in operation. The activity that is seen in the subscriber loops doesn't exist here. The access part is more active, whereas the trunk part is usually engaged in moving large volume of data from one point to the other. So you should understand the difference between subscriber loops and trunks. So these subscriber loops connect telephone subscribers to their local serving exchange. Trunks interconnect exchanges or switches. Usually, this can be, for instance, one of them can be higher or bigger exchange, or they can be equivalent exchanges. And for relaying purposes, there can be connection created between one local serving switch and another. This is what we call subscriber loop. Once we said this about the subscriber loops, customers, subscribers, and others, end users, we are going to categorize telecommunication services. Basically, telecommunication services can be categorized under this, three: voice, video, or data. And in general, we can call them easily be, provided by using wired or wireless systems. Basically, our study will be to see each one of them. Like, for instance, in this category, you can see so many technologies, like, for instance, the cellular telephony, and also the others, like, for instance, data services provided by the local area networks, wide area networks. Basically, the widest area network is the internet, and also the RF networks. Cable TV is also listed in here. CCTV is also there. So all technologies that you know of can be categorized under this, this formation, this hierarchy. So the service that you get can be voice or video or data. And then the technology selection can have medium, which is wireless or wired. So we are going to have this discussion one by one when we get deeper into the course. But for now, that you should know, services are categorized under this. And we also call them multimedia services. Later, we will have definition of broadband and narrowband types of systems, but as a service, you can just name them like this: voice, video, and data. To have some more terms, like, for instance, types of telecommunication companies or the different types of fields in telecommunications. One is known as service provider or operator. And those that supply the communication channels for voice and data transmission. For example, Ethio Telecom can be mentioned as an operator. Of course, it is more than an operator, as we shall see later on, because of its incumbent nature. Until other competitors come around, Ethio Telecom also provides so many other things, such as content as well. We will see that. The other field or the other category is equipment providers, and which are also known as vendors. You should not mix vendors and operators. Vendors have a sole task of manufacturing equipment and selling that to operators. That is their task. Those that supply the user and connectivity equipment, such as for telephones, for example. So vendors and operators. These are essential elements, as we shall see later in the service provision, and also the paradigm shift of service provision. We will mention them again. So service providers are operators. The operator has got the database of its customers, and also based on that database, and SIM cards and the likes are issued. So that is the operator. The operator provides the channels. Just to mention some examples of vendors, Ericsson is the one, and Huawei, And you can also mention some more, like Cisco, for example, they also provide equipment. They can be specialized in some part, in some portion, or they can also provide multitude of equipment. Like for instance, Ericsson and Huawei provide almost all types of telecom equipment, starting from the smallest to the most complex you can get from them. But some of them are concerned about networking and switching of data. Just to mention some examples, like for instance, Cisco and also Juniper and others, they are specialized in that aspect. So you have to differentiate the two. The other concept introduction that we would like to make is about telecommunication system. Earlier we had a discussion of communication system, but in telecommunication system we are going to deal with it, in more detail right now. When we say telecommunication system, we are referring to the collection of compatible hardware and software. You have to underline on this. Arranged to communicate information from one location to another. So they can be called telecommunication system if and only if they do what is mentioned in this statement. If you connect non-compatible elements, then information transmission or communication will not happen, and therefore we cannot call that telecommunication system. But once the system is operational, you can transmit data, voice, and video. In other words, the previously mentioned services, all of them can be entertained in telecommunication system. So if you are asked what telecommunication system is, you have to really mention all these aspects: compatibility, involvement of hardware, software, and also other essential elements. So in this telecommunication system, what do we have? First, you have computers to process information, and then you have terminals or any input or output devices. We call them peripherals as well, to send and receive data. And you have also communications channels, links by which data or voice are transmitted mechanisms. And most of the telecommunication system types are different at the physical and data link layer, where by data link layer we mean where they provide the medium access to the service. But starting from the network layer and above, you can say that all the technologies that we know are synonymous. The management, the operation is similar. Therefore, technologies are different basically at the physical and data link layer. So whenever you try to differentiate different technologies based on protocol, you have to pay attention or try to describe more the physical and data link layer. Like for instance, if I ask you the difference between ISDN and PLMN. ISDN is Internet Service Digital Network, which is basically the merger of the PSTN and also frame relay network, which is fixed, and PLMN is public land mobile network, the mobile network. Their difference is at the physical and data link layer. At the physical layer, the mobile network doesn't have guided medium. It is wireless. Whereas the ISDN network has got cable or guided medium. This is physical. And then the data link layer, the access mechanism is different. Basically, the PLMN approach or other wireless approach is carrier sales multiple access collision avoidance type, whereas the fixed type might use the one that can be employed by Ethernet, which is carrier sense multiple access collision detection. So these are essential elements. Telecommunication system components, there are also two more. The communications processors. This provides support function for data transmission and reception. Basically, from the previous case, the terminals to send and receive data, the communication channels links by which data or voices are transmitted, Like you can have time slots or frequency bands in this case, in the channel. This one, the communication processors provide support function for data transmission and reception. Like, for example, you can have modems, multiplexers, controllers, front-end processors. You can have, for instance, in the DSL technology, DSLAM can be considered as a communications processor. And also, there is CMTS in cable TV services. Or those types of elements are known as communication processors. The other important element is the communication software. Communication software is not a single software. We will discuss about later on. There are several types of software, but this is very important and essential element of the system. Unless you have this software, then you cannot have all the signaling precedence, and therefore you cannot have a system. Because in the definition of the system, we said that compatible hardware and software, and with in the result of transmission of information. Unless we do that, we cannot say that is a telecommunication system. So this is essential element as well. So generally you have 5 of them, telecommunication system components. Now let's talk about protocols. What are protocols? Protocols, before we talk about protocols, we have to talk about standards. Standards are high-level decisions. To just ratify standards, a certain person doesn't need to be a technician or a scientist, something like that. Decision makers, for instance, can gather at the UN and talk about the importance of some service. And they might outline the types of services they need. All these talks, and which are decided by high-level bodies, they provide us with standards. So you have standard, which is the rule, in the high level, communicated between individuals, and then after that, when you try to bring that talk to the ground, to the service, you need to have protocols. So therefore, protocols are driven from standards. Protocols are essential in order to provide the service. And to create what we call signaling, we need protocols. Protocols are a set of rules and procedures that govern transmission between components in a network. The process of doing that is known as signaling. Therefore, you have to know that protocols emanate from standards. Standards are talks, agreements that exist between individuals. So generally, protocols are a set of rules and procedures that govern transmission between components in a network. And the process of doing that is called signaling. So what are the principal functions of protocols? The first one is to identify each device in the communications path. Because whenever there is some sort of communication or transmission of information, the elements should first identify each other. That type of scenario exists because there is protocol. For example, a certain router knows the other routers around itself. Identification is essential, and then because it knows the routers around itself, the routing table also contains a column known as next hop, if you have seen routing table. So this is very essential part of the protocols used to identify each device in the communication path. The end user, the terminal, should identify the local exchange. Or a certain client should understand or should know the server. All these issues are very important. And the first use is to identify each device in the communications path. The second is to secure attention of other device. For example, if, for instance, in certain sensor network, one element wants to send information to the other, first it should send attention. You can also have that type of task in Ethernet. There can be a certain device using the Ethernet line, and then the other elements know that one element or one terminal is using the line, and therefore they refrain from putting their own information into the system, into the type of, the other purpose of protocols. The other is to verify correct receipt of the transmitted message. Like, for example, after a certain message is transmitted, acknowledgement is sent back. And in this case, we have what we call connection-oriented type of transmission. Or you can also have best effort type of scenario, and you should have a mechanism of knowing how the message was handled, the sent message was handled. So this verification process is also part of the function of protocols. Then you have also another use to verify that a message requires retransmission. If there is no acknowledgement in the previously mentioned scenario, then the sender understands that transmitter message was lost, and therefore, after waiting a certain amount of time or by fulfilling some conditions, it will retransmit. This is also to verify, verification of, requirement of retransmission. The other is to perform recovery when error occurs. So, as you know, in channel coding from your other courses that you might have taken earlier, you have two mechanisms: error detection and error correction. So those types of issues are also handled by the protocol. So to perform recovery when error occurs. Of course, there are also so many types of services which are also related to security, and also different types of formats, for instance, format exchange, and also like compression and also other types of tasks. The requirement of all those functions are also outlined in the protocols. So there are so many other services of protocols, but these are the main ones that you should always understand. So these are the functions of protocols. Like that, now let's see with block diagram, talk about telecommunication systems. Telecommunication systems, whenever you have a certain system, tried to mention it earlier, you have this part, which we call access. And then you have the trunk network part, which we call distribution and core part. But since this can be like black box, we would like to have more sophisticated type of analysis by putting it into separate sections. When you have huge network, you can have the access part, you can have the edge part, you can have also the distribution just next to the edge, and you can have the core. And in the other end, you will have also a similar trend. So access part is terminated by terminals. Like, for example, if you have a PSTN network, you have the local exchange, and also the local exchange talking with the terminals. If you have cellular mobile network, the nearby base station connecting and also exchanging message and signaling with the terminals around that place. But the domain should be the customers of that particular technology. So the network nodes and links are optimized for certain assumed traffic patterns. Like, for example, in our earlier course that we had, as you remember, in high performance networks, we had a queuing theory assessment analysis. And then during that time, we discussed about offered traffic and carry traffic, and also the grade of service in that system, when we talked about traffic engineering in particular. So this is the part where the traffic randomly comes, and all the requests coming from the terminals or the access part constitute what we call the offered traffic. In expansion of systems or in trunking theory and others, the offered traffic or the traffic intensity is the one that should be considered. In addition to that, you need to have the decision of the operator about the grade of service. All those issues are also parts of the discussion of the access part of the system. And in the distribution part, on the other hand, you need to have other concepts such as MPLS and the likes. So you have different types of assessments, points of view of the discussion of the access part, the discussion of the distribution and the core parts. So this model applies for both data, packet, and voice networks. It also applies to any type of technology that you can have. It can be wireless, wired, whatsoever. All of them can be, modeled by using a block diagram, like this one. When you get into details, of course, everything will be different. In particular, at the physical and data link layer, you can have huge differences. And also the services provided will be associated with the type of, the mechanism of access that you provide. In some services, you can get flexibility, mobility, and in some other services, you cannot get that. And in return, you can get reliability of services instead. A certain level of quality can be obtained according to the type of access mechanism that is provided and which is basically determined by the physical and data link layer. So this is a simple block diagram, but you can apply it to any type of technology. Getting into the details, that is a complicated task, and in some instances, we are going to see that as well. So you have commonalities. So since you have this type of similar architecture, while not delving into the differences, common issues exist, and therefore those common issues should be also parts of the discussion that we are going to have in the future as well. Our next discussion is the service provision and the paradigm shift that we are witnessing. This is a traditional view of service provision, the one that you see at the top. In this traditional view, there is a network. The network has services, and services have subscribers. Whereas the one that you see at the bottom, it is a different issue. Users have services, and services have networks. So since this is quite a good discussion, type of discussion that I want, and also I would like to have with you, since we are going to talk about the deregulation, privatization, and other issues in consequent discussions to this one, I would like you to read and also try to understand these two concepts first, and then we are going to have further discussion in our upcoming lecture. But for now, since we don't have that much time now, I'm going to pass it for today, and then we are going to meet in our next session. And in the coming session, we are going to discuss more on this, the paradigm shift, and also other related matters regarding this privatization, regulation, and also the key market players in the telecom industry will be discussed by our coming session next week. If you have questions about the discussions that we had this evening, you can ask me. Do you have questions? Up to this point, of course, we are going to continue on this discussion just in the coming lecture time. Okay, so if no questions, then I will see you next week. I'm going to have an assignment, reading assignment about these two views, the traditional and the new approach. And then you can also illustrate your discussion by examples. Which one is better? If you have some sort of argument against retaining the first one, and if you say that is not the way to go, you need to also discuss and explain whatever you feel in that reading assignment. Have you got the point? Your assignment, your reading assignment is comparison of the two views, the advantages and disadvantages of the two views. And also, if there is any disadvantage, if there is any advantage from both of them, then you are going to explain that. So this will be, I think, your first reading assignment. Did I give you another assignment earlier? ተሰጥቷችሁ ነበር አሳይመንት? ማንም የመለሰ የለም። ኦኬ። ስለዚህ ይሄ የመጀመሪያው reading assignment ነው። You are going to compare and contrast the traditional view of service provision and the new approach. And in that, if you have some argument on retaining the first, I mean, not changing it to the privatized one, you should also present your reasons. And if you say the other way around, this is harmful and we should have the privatized approach, the new approach, you have to explain that as well with some illustration, with some examples. So this is your first reading assignment. All right. So saying that we will have also another, discussion on the key market players in the telecom industry later on this lecture. And now let's continue our discussion to the next topic, the start of service integration and also the creation of network known as ISDN, the Integrated Services Digital Network. This has got its own story. As you know, traditionally there was a PSTN network, public switch telephone network. And with this network, you can get voice service. And probably with dial-up, you can also get some data service, which is not as good as you might think. So basically, the PSTN network is designed for voice services. So during the start, there was no the idea of providing data services by using the PSTN infrastructure. And because of that, another protocol was adopted. The first protocol that was adopted to provide data services was X.25. And later on, because of its shortcomings, X.25 evolved to what we call frame relay. The first type of data service that could be provided alongside the voice services, which was also provided with another infrastructure. So if somebody wants to have data service in addition to the voice services, it was a must to have another subscription with a different type of infrastructure, which was basically frame relay. That lasted for a while, and after some researches, it was proven and also shown with experiments that the PSTN network could also be used to provide data services by using a protocol known as DOCSIS, data over cable type of scenario. And that led to the merger of the two technologies. PSTN and frame relay merged together, and they created what we call ISDN network. You can see here you have the merged networks. And when they merged, data services and also voice services could be provided together. The types of services that were provided by using this ISDN network, Integrated Service Digital Network, were classified to be narrowband ISDN and broadband ISDN. In addition to this, ATM infrastructure also evolved from frame relay network. And with this ATM network, voice and data services and broadband services in general were provided. So therefore, this is the first merger that is shown to be an advantage. We will have convergence discussion later on in the last lecture of this course. But this one happened, and also with that, so many advantages were obtained. From aesthetic value to other types of simplicity in management was obtained, and the story behind ISDN is like that. There was PSTN, there was frame relay, separate infrastructure for data, and then the two merged together to create what we call ISDN network, Integrated Services Digital Network. The type of signaling implemented in ISDN, as you know, is signaling system number 7, which is also the de facto signaling system in PLM main networks, public land mobile network. So when we say this broadband ISDN, we are referring to the types of services such as DSL and the likes. Because as you know, you have different types of DSL services. There is ADSL, SDSL, and also others. These are parts of the services provided by ISDN network. And this is also one of the leaps of technology in the telecom industry, when the voice and data services were provided by a single infrastructure known as ISDN. This ISDN network also served as a benchmark for the development of other technologies. That is, public land mobile network, the cellular mobile network that we know is also imitation of most of the services provided by the ISDN infrastructure. Except that in PLMN, you capitalize on mobility and other issues, and the channel that is implemented is wireless for the flexibility purpose, but most of the signaling and the type of service provided is imitation of ISDN infrastructure or ISDN network. So this merger also helped to provide differentiated services like transportation system channeled into constant rate, real time, and also different types of latencies. Like, as you remember in our discussion in high performance networks last time, ATM can provide these differentiated services by quality, of course. Quality of service based category could be obtained by using ATM network, which is also an advancement of frame relay. So you could say that the coming about of ATM and ISDN networks, the time, the duration is equivalent. But the quality of service provided was not comparable. Like we mentioned it in high performance networks, ATM is an exemplary type of network or technology, which provides promised type of quality. And also the end user license agreements are also very vivid and also with quantity. They can promise certain level and then they can provide it. And that is not comparable with the ATM infrastructure that we discussed earlier in another course. But this is about ISDN networks. So what are the different ISDN service access mechanisms? We have different service access mechanisms. First one is the PSTN network. As you know, this was original network, which supported only voice services. Then the other is CSPDN, circuit switch type PDN, packet data network. And the other is PSPDN. This is a packet switch data network, and analog dedicated lines and digital dedicated lines. All these are included within ISDN service access mechanisms. As you can see, ISDN protocol supports only guided medium. That is why we require another type of protocol, which is an imitation of this type of service provision, known as public land mobile network, which basically capitalizes on mobility, ease of access, flexibility, and other issues, which can be discussed in different mechanisms of access. So we are going to discuss different technologies in our upcoming sessions as well. But these are the different ISDN service access mechanisms. Well, we have different standards of ISDN. which are basically accessible online. You can also go to the ITU website and also look for ISDN standards. These are the referent ones, like definition of user network interfaces, inter-network interfaces, maintenance principles, equipment aspects, service capabilities, and overall network aspects and functions are defined in the ISDN standards. So still, the fixed access is highly dependent on these standards. So you can go to the ITU website and also have a look on that standard definition of ISDN. This is just if you would like to see more of this. The other one, which is important, fundamental concept, is to discuss about public land mobile network. I tried to mention it earlier, and as I just told you, this PLMN public land mobile network is defined based on some subsystems. Like, for example, this is a generalized type of DOM technology. PLMN is not a single technology. It is part of a standard, just to put it in short. So what makes a certain network part of PLMN, then you should have three subsystems in there. The first one is the base station subsystem or radio part, regardless of the technology implemented. The other one is the network switching subsystem, the NSS subsystem, which is basically designed for database and also switching purposes. And the other one is the management system, network management subsystem. Any technology that has got these subsystems is categorized under PLMN. Therefore, if you have different vendors, if you have different operators and also the equipment provided by different vendors, then you can have that many PLMNs. Therefore, the PLMNs throughout the world are numbered in millions. Probably so many of them, which might be minor types of technologies. Just to mention some, for example, we have different types of deployments in our country. There was once Nokia network, there was also Ericsson network, and also ZTE network. All of them can be considered to be PLMNs because they possess what we call the base station subsystem, network switching subsystem, and network management subsystem. So there are so many public land mobile networks throughout the world. The technology might be based on CDMA, TDMA, or anything else. As long as a certain system satisfies these subsystems, it is known to be part of PLMN definition. So, for example, if you see the GSM hierarchy itself, before GSM, there was NMT, the Nordic Mobile Telephony. The analog NMT was also PLMN by definition. Because even though it was analog, the base station subsystem, network switching subsystem, and also the management was there. GSM, GPRS, H, WCDMA, all of them, they are also PLMNs, public land mobile networks. So the thing is, the signaling method that is implemented in PLMN is similar to the ISDN network that we discussed earlier. That is why you can have call from cellular network to fixed network and from fixed network to cellular network. That is possible because you have some access, some sort of signaling mechanism that is, mediating both of them. Signaling system number 7 or SS7 is understandable by both PLMN and ISDN networks. And as I told you in my earlier discussion, protocols are the ones that are interpreted that are used to develop signaling. And therefore, that development was done both for ISDN and PLMN. Deployment of ISDN was earlier compared to the PLMN, which was implemented, of course, in full definition of standards later, after a few years. And then the merger of mobile IP networks will be discussed later on, as you might have, discussed it already. There are different types of representations here. Mobile IP and fixed IP is another concept which might not be, discussed here. But the thing is that you have some sort of merger concept, backward compatibility, and support for data flow and other issues discussed in the standards and also developments of PLMN. As PLMN network is copy or imitation of ISDN networks, you should expect some of the principles that were adopted in ISDN to be also part of this definition. So just to see some of the technologies, the well-known technologies which are in the PLMN domain, WCDMA is one of the famous ones. Most part of the world is in 3G era, except that some of them are leaping to 5G, and the rest are in the 4th generation era, but most of the world, in particular the third world countries, are in the 3G era. And data services from cellular mobile networks still remain very expensive, and the world uses other mechanisms of data connectivity. For instance, the cost of data services from cellular networks is 3 times as expensive as the cost of data services from Wi-Fi or hotspot services. And because of this, that aspect is going to improve. And for that improvement, the previously mentioned service provision model contributes a lot, particularly the one that is considered to be the new approach. So in this UMTS service, the UMTS is the Universal Mobile Telephony System. UMTS is DOM technology, and within UMTS you have also WCDMA as one part, and also you have also other services like TS-CDMA, the Chinese counterpart, and also CDMA 2001X, and also the rest. They are parts of UMTS definition. So to arrive this to UMTS service provision, basically first you have to traverse these generations. The first one is GSM. After that you have GPRS, General Packet Radio Services, which can provide a better data service compared to GSM, which is very low data rate as shown in here. And HSCSD, high-speed circuit switch data, is better than GPRS. EDGE is the one that is just before the growth towards UMTS services or WCDMA services. So in all these narrowband systems, we call them narrowband. This one, GPRS, HSSD, and EDGE. The implementation of VC packet switching approach is used. Virtual circuit packet switching type of technology is implemented. And because of that, you have the definition of fixed IP and mobile IP concepts. The mobile IP concept is used in order to have connection with the home agent that you have subscribed for. For example, your subscription might be in Addis, but for instance, if you go to Bahar Dar or somewhere else, and if data service like email and also other things are sent to you, you should have the mobile IP implementation there taken care of, and then you can get the data service by your given IP address from the network that you subscribed for. So these IP concepts are used, and when we say merged mobile IP networks, the fixed IP concept and the mobile IP concepts were treated as similar with top-up protocol architecture design. And that is also one thing you should mention. Like we did for ISDN networks, differentiated services or service differentiation is also one of the targets of UMTS. It was one of the targets of UMTS, but unfortunately, the effectiveness of this service differentiation is not as good as the fixed network. That is quite expected. That you should also note that. And the different types of classes are, for instance, the conversational class. This one is very delay sensitive traffic. The other is streaming class, interactive class, and background class, the most delay insensitive type of service provision. Since UMTS service is based on IP concept, even though it is circuit switched type, VC, virtual circuit packet switch technique. As you remember, VC packet switch technique, probably we might have covered this in our other course, which was high performance networks. But this service category is based on the IP principle. As you remember, IP has got header, and in the header part, for different types of protocols like TCP and UDP, you have different types of headers. IP header exists in general. And in the IP header, you have type of service and other issues covered. So that helps for the category formation that you see here. So UMTS is one of the important types of DOM technologies that can be mentioned within PLMN, public land mobile network. And in order to get this UMTS or 3G service, there was a protocol group, as you remember, 3GPP was used. The third generation partnership project was a project or a committee that was organized to transform the existing 2.5G and 2G networks to 3G. This is for the European part, from GSM towards 3G, or what we call WCDMA. For the American part also, you have the transition from the already existing IS-95 to CDMA 2001X and related upgrades. That particular project is known as 3GPP2. 3GPP and 3GPP2 are the two main and very famous projects. And 3GPP is still alive and is developing protocols for 5G as well. You can go to the website of 3GPP and check that for yourselves. 3GPP is very active and still developing standards and also others, interpretation of protocols, everything in 4G and 5G as well. Of course, in 5G, the pioneers are not the Western countries anymore. You might have heard of this. The Far East Asian countries are dominant in the overall development of 5G. The West, for now, is taking the support group, and METIS 2020 is one pioneer type of group that you can consider reading about, but we will have a separate lecture about that, and you will get it when we arrive there. But for now, you should know that this is very important comparison that you have between ISDN and PLMN, and we have mentioned UMTS from PLMN because it tries to imitate the ISDN network by creating class via differentiation of the IP header type of data service. IP was initially designed for best effort type of service. So you can use UDP as well. But in narrowband systems, usually the circuit switching technique, the virtual circuit that is created is very helpful. And because of that, in UMTS and other services, you do not have the problem of jitter, like in IP networks. All right? So saying that, let's talk about the telecom market players, which is another important section in this discussion. Earlier, the paradigm shift of service provision was mentioned. The traditional view and the current view, or the new version, was discussed. Now, what are the telecom market players? As you can see, there is end user, and there is content and service providers, and there is service operators, telecommunication network solutions. They are also called that, that term. And there is physical telecommunications network. Now, when we discuss these things by example, I would like to mention Ethio Telecom one more time. As you can see, Ethio Telecom fits into, in the three of the categories that you see here, which is not common throughout the world. In other countries, the physical or the infrastructure owner and the operator and also the content and service providers, they are separate companies. They have got even some rules that prohibit association of service provision, operation, and also infrastructure owning. And because of that, the deregulation that happened in other countries is not only on the service provision, but also on the infrastructure as well. This goes to other sectors as well, even in energy services and also in the banks, the same situation is adopted. So anyway, these are the market players. And there is one influential group that is not mentioned in here because that part is known or assumed to be part of the governance in any country. The regulator part is always vigilant of all these parties that you see. The end user, the content service provider, service operators, and the infrastructure owners. So these are the market players in the telecom industry. In particular, the service operators or the service providers highly depend on the end users that they possess. They should have acceptable and viable market plan or business plan in order to stay in the market. In the countries where there are 3 or more operators, it is always competition to have or to retain users in their own services, because at the end of the day, the end users are the ones that pay for everything that they have for the operators. And so this relationship between end users, content providers, operators, and the infrastructure owners is intertwined, and one cannot exist without the other. That is a very essential term. They create what we call an interoperable hierarchy. Telecommunication network content and technology producers, operators, and consumers form an interoperable hierarchy. This is a very essential concept. So just to have some definition, end users, they can be individuals and companies. We also call them subscribers. The other one is information or service providers, which also call operators. Like, for instance, they possess the database of the users that they have. For example, you have Ethio Telecom as an operator. Ethio Telecom knows your identity, and then that is kept in a database. And then the copy of that database is given to you as a SIM card, which is identification module, subscriber identification module. So those are known as operators. But in this type of service provisions, there are also what we call service brokers. Like if you see the diagram that is shown in here, there is network operator here. And this network operator is highly dependent on the content provision. Contents can be provided by different entities, like there can be a company, established institutions that can provide content. or there can be individual that can provide content as a freelance journalist or something else. And then that content will be a very essential competing factor for the network operator. The network operator that gets the content first will win the end user. As you can see, the network operator can sell service to the end user directly, as is shown in here, or that can happen through a service broker. Service broker might add some value on that and sell it to the end user as well. So there are so many players in the telecom industry, the telecom market. Since our country has not opened up yet for these types of competition and business, most of the terms that I mentioned right now are not visible. I mean, are not, something that you can comprehend right away to their extent. You know them, but this is a huge market that exists in the other, countries. Huge market exists. The content provision, the quality is highly dependent on competition. So the existence of competition is mandatory because we are, I think among the last countries to have these deregulation issues. When there is this competition, this market player, there should be an intelligent body that should govern this operation. This might be also a cheating podium for the end user. There should be a proper regulator, intelligent regulator, to oversee what is happening to the user, what the operator is serving, the tariff and other issues should be properly, investigated all the time. As you know, we have ECA right now, which is in its infancy stage, I could say, because it is only 2 years old, right? ECA, Telecommunication Authority, is the one that takes this role, I think. But it is very essential and important task that it has got. Because when these operators come around, as I mentioned it earlier, probably I mentioned this one, what do you think is the target of any operator? What is the purpose of an operator in general? Telecom operator. Anyone? You can raise hands to answer. Okay, Taye.
Providing service to subscribers or individuals and getting money in return.
Exactly. The last part is the answer. They are always after revenue. The other is accessory. Whatever they do to the customers is to get to that revenue. We should not be misled. So the thing is that since they are after the money, they would like to get it by hook or crook, and therefore proper regulator is important. There should be overseeing of the services provided, the rules of the land, and also other issues. That is why when we have this deregulation issue, privatization issue, we should always be prepared for such types of actions. When the operators come, they might be, located in the areas where they can get so many customers, like in the cities. They might ignore the countryside. Therefore, there should be some rule, some governance to force them go there. All right. So that is, important point to take. So this is just to give you an example. As you can see, these are the telecom market players, and also in most parts of the world, these are separate companies. Probably, in the telecommunications infrastructure alone, you can get multiple companies as well. Even within one layer, you can get so many companies, probably taking the infrastructure by region or other types of approach. So this might be the next trend here in our country as well. So this is about telecommunications market players. please have a look at it, understand what is happening between these end users, content service providers, service operators, and also the difference between each one of them in general. And we usually have separate companies for each one of them. The same type of principle is adopted in energy service provision as well. Like in the electric power, for example, we follow similar trend. The infrastructure and the service provision, your license agreement will be with all of them. That you should know as well. To get a certain service, you agree with the operator about the services provided. You agree with the infrastructure owner about the maintainability and also other issues of the infrastructure. Because of that, the type of service that you get in other countries is kind of different compared to our own. And also because of this competition, you should expect lower tariff as well. That way they can retain end users. For all of these to be sustainable, the end users are the ones that pay for it. When there is some tariff set, then the end users are the ones that will pay for everything, for the capital expenditure, for the maintenance, for subsistence and salary of the employees of the operators as well, and also the infrastructure owners. So all those issues should be considered. And this is how you can discuss about telecom market players. Well, this is about the market players. The next discussion will be about elements of telecommunications that we are going to pursue in our next class, but I would like you to read more on this part, like to read about the telecom market players and also the paradigm shift that I mentioned earlier. The paradigm shift is given for you as a reading assignment, but the telecom market players, understanding every item in here is very mandatory, because there can be, some sort of question from this one during your examination and something else, right? So if you are told that it is going to be there in the exam, I hope you are going to read about it. So please read and understand each and every term in here. If you have any question about our discussion today, you can ask me. Next time we are going to briefly see some of the contents in here. But since I'm going to send you the lecture notes, you are going to read the most part of the remaining part of the lecture, and in our next session, we will start the second lecture as well. But now, based on our discussion today, if you have any question, you can ask me. The first one was about deadline, the first reading assignment. Okay. ይሄ ከሁሉም ሰጣችሁ ሪዲንግ አሳይመንቶች ፋይናል ኤግዛም አንድ ሳምንት በፊት ተጠናቀው መግባት አለባቸው። ልክ ፔፐር ሪቪውን ጨምሮ ማለት ነው። ስለዚህ ከአሁኑ ስራ መጀመር ይኖርባችኋል። ፔፐር ሪቪው እንዳላችሁ ታውቃላችሁ፣ ባለፈው የተነገራችሁ ነው። አሁን ደግሞ ሪዲንግ አሳይመንት ተሰጥቷል። ወደፊትም በመካከል ሪዲንግ አሳይመንት ይሰጣል። ስለዚህ ከፋይናል ኤግዛም አንድ ሳምንት በፊት ሁሉንም ታስገቡ። The other question that Brahan raised is disadvantages of mobile network and how mobile IP works. Well, whenever you have a certain technology, there is advantage and disadvantage, but usually a certain technology is kept because the advantages outweigh the disadvantage. If you would like to compare mobile, in general, wireless network and fixed network, bandwidth issue, stability, and also other properties are not the same. Usually, a guided medium has got predictable type of behavior, and also quality of service can be kept when you have that type of predictable behavior, which is wired type of communication. Whereas you will not get mobility in the wired or fixed type of communication, whereas in cellular mobile networks, you can get mobility and other advantages. We can go on, on the list, like deployment cost and other issues can be mentioned. But to make it short, the disadvantages that you might mention in mobile networks and wireless networks in general is that you have wireless channel, which is highly random, and you require sophisticated technology to keep certain level of quality. That can be easily obtained in wired communication, fixed networks. How mobile IP works, you also mentioned that. Well, there are so many pointers, but the thing is that you have home agent and foreign agent. In the home agent, you are given fixed or static IP address. When you move around, you will leave care of address to your home agent. And when some message comes to you, you will be found by the care of address that is left in the home agent. The foreign and home agents will talk with each other. That is, in short, Brahana. If you are interested, you can read more about that. Okay, that's just to keep it within the scope of this, discussion. The mobile IP is encapsulation of IP address within another IP address, in short. So that is in simple terms. Another question that did I answer your question, Brahana? Okay. The other is Mati. How can the new telecom operator can deploy the service? Okay. Well, if you follow up the news, an operator, a consortium of operators has won, the first one, and we will have another one in the near future. The thing is that the infrastructure, most of the infrastructure is owned by Ethio Telecom. There is no limitation on the operator whether they can bring their own infrastructure or not. If they can bring infrastructure. But since Ethio Telecom will have most of it there, it would be better for the country if Ethio Telecom can lease the infrastructure for these newcomers. This is not forced on the operator, but the operators also have got the advantage of infrastructure lease from Ethio Telecom. So for the coming many years, Ethio Telecom will be the one that will be dominating infrastructure. Most probably, since the customer care and other issues will not be competent with the coming operators, in my view, Ethio Telecom might not be that competent in the service, but they can still keep the infrastructure for a while because it is owned by Ethio Telecom right now. That is how the service operators will perform. Did I answer your question, Mati? Is he in or out? I don't see his answer. Okay, nice. So we will discuss more about these issues in the coming lecture sessions as well. You can ask by just speaking the mic rather than writing with text. It is also all right to text, but I prefer if you just grab the mic and ask. All right? So that is all for today.